All right. Hello, everyone. I'm Joël Franušić. I want to make all software from all time instantly available for use by any programmer. And here with me.
Hey, everybody. I'm Adam Smith from UC Santa Cruz. And among many other things, I want to make a new kind of search engine that looks within and across the contents of interactive media, like apps and video games.
So let's go back in time to the mid-1850s and talk about Alice in Wonderland. So who here has heard of the phrase of falling down the rabbit hole? This is where it comes from. So this is a copy of the book Alice in Wonderland in the Library of Congress. And what you see highlighted here on the screen is the section of that text that talks about that moment in Alice in Wonderland. So this is something that we're all familiar with, quoting text. And this is what we can do if we want to remember a particular part of a work, if we want to compare that work with other texts. And this portion of the text is about 2.5% of the total work. Similarly, if you watch that moment in the Disney movie, this is that same moment we're all familiar with getting a clip of a movie. If you're taking a media studies class, this might be something that a professor would assign to you. You can use clips to compare different works with each other. So there are a lot of stage productions of Alice in Wonderland. And if you wanted to compare and contrast this moment, this is what you could do. You could have a clip of a movie. But what about video games? How do you quote video games?
Like, really, take a moment to think about it.
All right. Well, you can do a gameplay video, right? You can watch somebody playing through a video. This is a moment here from the Game Boy game Alice in Wonderland. It's the same moment of Alice going down the rabbit hole, but this clip itself, just this clip, if we were to trim this out, it's 4 times larger than the entire ROM. So in terms of space, it's not that great because it's much bigger than the original work.
And it's not even interactive.
Yeah, you can't get a feel for what this is like. So what can we do about that? Well, here we have a playable quote. So this is that same moment of the game, but it is only about 5% of the original ROM. And if we click on it here, you can see it looks similar to that video that we were watching. But there's something new here where I can take over control, and now here I can go to the left, I can go to the right, I can slow down, I can speed up, and so now I really have a feel for what is happening in this game. So here is a playable quote. Close that off. So, to briefly summarize, we've talked about how you can quote text. This is something that we're all familiar with. We can quote video. We talked about the limitations of game video and introduced the idea of a playable quote. But what is a playable quote? So this is what we're going to be talking about today. In the research that Adam and I have done on playable quotes, we've identified the 4 areas that you see here on the screen. So in terms of playability, you've already seen that. You saw me interact with that game quote, and I was playing it. We also saw this aspect where it's performative. So before I took over control, you were seeing the original gameplay of when I first recorded that quote about a month ago. You saw, it was moving back and forth, and so you got an idea of what you should do in that moment in the game. But there's 2 more aspects that we haven't covered. So there's this idea of a quote should be partitioned. It should be a smaller piece of the original work, similar to how a clip of a quote of text is smaller than the original work. A clip of a movie is smaller. And it should also be permanent, something that you can use not just for this particular moment in time because, it's not dependent on a particular version of a Linux kernel with a particular version of an emulator. It should be something that you can use 10 years, 100 years into the future.
And think about it like maybe if the original game was lost, we want the quote to still be playable. That way we could have, we'll get into it later.
Yeah. So let's talk about this partition. So who here has seen Blackout Poetry before? Blackout Poetry, for those of you who haven't seen it, is this really neat way of writing a poem using an existing piece of text, and you will literally go and black out all the text that you don't want and leave just the parts that you want. And that's a really good analogy for what we're doing when we partition a quote. So that game that you just saw me play, that quote of Alice in Wonderland, is visualized here next to that Blackout Poetry. This is a visualization of only the parts of the ROM that were needed for that particular moment in the game. So all of the big black empty pixels, those are all zeros. So we literally recorded or traced what was happening during gameplay, made a list of only those portions of the ROM that were used, and then we zeroed everything else out, and this is what it looks like when you visualize it. So the little colored bits, those are the color value more or less maps to the value of that byte. And so you can think of, one way of thinking about what we've done is part of a quote is this mass ROM, which has been emptied out of everything except for just what's needed for that portion of the game. Another way to think about it is this visualization here. So here on the left with the white background, you see gameplay of Tetris. And then here on the right with this dark background, you can see the memory accesses happening. So you'll see little things flashing, but you'll note that in this portion of gameplay, there's only a kind of a fixed portion of the ROM that's actually being used. And all the rest is never really used either. So this is another way of thinking about like what is actually going on when you're recording a quote. So here's yet another way of looking at this. So let me explain here what we've got on this here. So on the top row, this is roughly what the screen was looking like at that moment in time. This row here, second from the top, is showing basically the average pixels per row. So what it looks like here is, what it's visualizing is you can see these pieces dropping down. So here's a piece dropping, here's another piece dropping. And then in this big part here, these are the access patterns of the ROM over time. And you'll notice when it's rendered this way, you can see, over time, there's just huge sections, like here in the middle, that aren't ever really read. And there's a little bit here in the beginning, but over time, very little of it is used. And that is also visible here at the very bottom, where we graph out over in that portion of time how much of the ROM was actually used in that portion of time. And you can see it stays fairly consistent, around 5%. So this is the partitioned aspect of it, where we found that at any given moment, only a very little portion of the ROM is actually used. So how do we get there? The beginning of playable quotes, as Adam and I were talking about it, we weren't even sure if this was going to work. Like, we would talk to other computer scientists, and they're like, this is never going to work. We'd come up with all these reasons why it wouldn't work. But to get started,
Just a brief comment. How many of you have heard of program slicing? Well, a few people. What we're doing is a kind of program slicing, but under different constraints. But it's definitely related to that scholarly tradition.
Yeah. And so, so what we did is Adam and I set aside some time and we picked PyBoy. So this PyBoy emulator is actually really nice. It's very clean code, very easy to understand and use. Really liked it. And each of us took a different approach to exploring PyBoy. But the idea was to just monitor a gameplay and get a list of all the bytes of the ROM that were used. So Adam used a Jupyter notebook, wrote a fancy plugin to snoop on all the different memory access patterns. I did a much more primitive approach where I was actually like editing the code manually to do that. But the idea was to build a log out that would allow us to make an allow list to basically say, we're going to only allow these particular ranges in the ROM to be used. And then we each separately modified our version of PyBoy to have a plugin that would check. So when the emulator would go to read a portion of the ROM, we would have a hook to basically say, like, can you read that portion of ROM or not? And the big aha moment for me was when we were able to exchange our allow list with each other. So we transmitted the allow list over the internet to each other, and we were each able to play a quote that the other person had made. And that was like the big aha moment for me, was like, it works. You can actually play a game where you strip out most of the ROM and just with this allow list, have a playable game that you can have within this tiny constraint. There were a few problems with this. In particular, there was a game I wanted to build a quote from, and it just didn't work. But we'd also wanted to make something that worked online. So we switched to the Game Boy Online project and used that to build the same thing, but have it on a web page, so that you didn't have to have a particular version of any software running. As long as you had a browser, you could use that. And the cool thing about this is that we didn't even have to modify the code. We were able to just monkey patch the existing code and add our capabilities on top of it. So here's a brief bit of code. There's more, of course, in the prototype or in the implementation that we built. But the cool thing is there's this neat proxy function. How many here have used this before? Ah, okay. So this was something that I really like. It allows you to modify existing JavaScript, and what you see here is that we've overridden the get operations. So when other code, the code in this project, goes to go read from memory, instead of it being read from memory, we hook into our existing, or hook into our own little function that will check that allow list, and then, you know, if that portion of memory is part of the quote, we will let you go through. Otherwise, we'll load some code up that will handle that condition of like, oh, this part of the quote isn't available. And so by default, we just reset, but we have a hook in there so that you can decide what you want to happen. And so the cool thing about this is with that capability, we didn't have to modify the code at all, and it's would have been difficult to modify because it's very like compact and optimized for speed. So having this ability was really nice. So here's what it looks like. Let's go and take a look at Tetris. I don't want to load that one. I'm going to go and load this one here. So this is what the quote looks like. Again, that's Tetris. But if you look here up on the screen, here we just have a URL. So this is just a simple player. The only input is a URL, and you'll notice it is a URL to just an image. That's the image. That is the quote. So everything needed to run that quote of Tetris is in this image. And you might be wondering, how is it in the image? Well, if you turn your head sideways, you can see here 8BPP, steg, zip. The way that we encode the game into the So this here is what it looks like when we steganographically encode the zip file containing the quote into the image. Adam played with the contrast, and you can pop out these like little different colors here. And this is a technique that came from the creature creator in Spore. It's also used in the Pico 8 fantasy emulator. There's a bunch of different ways you can join a zip file into an image, but this is the most durable. So if you want to share a quote over social media, like you know, the like popular ones like Blue Sky or Mastodon, this will stay. This will keep all of the data so that you can like see your friend will post a quote that they made, and you can just take that image and put it into a player, and it'll just work. So what's in a zip? Let's take a look. So the zip file contains 5 basic things. It has the copy of the original ROM, but with everything that's been masked out. It has a separate mask because you can't know whether, you know, a 0 in that masked out ROM was meant to be 0, or if it's one of the portions that we emptied out. So we have a mask that lets the emulator tell whether that portion of the ROM is supposed to be read or not. And then we have a save state for the emulator. So the quote starts from a save state. So from the moment in the game where you want to have that quote start. And then we also have a record of all the controller presses. So this is what has that performative aspect where you can see what was originally done in the game. Those button presses are read from this file here. And then finally, we have some metadata that we put in there, just plain old text, and that's there so that if somebody was to find this and figure out that it's steganographically encoded, and they were to pull it out, then it explains what's in the quote, how it works, how to kind of recreate it. So 100 years from now, if people have forgotten what quotes are, but they run across these files, they'll be able to extract out the zip and see what's inside.
Like if you had to go get the data from the GitHub code archive, you could find enough data there in order to bring these quotes back to life.
And then finally, we've got a screenshot, but the cool thing is the screenshot's already in the quote because it's that PNG, and that's the screenshot of the moment that the quote started. So if you want to read more, you can go and find this paper. So Adam and I presented this at the Foundations of Digital Games conference earlier this year. We've got all the details in this paper. So that's that.
Joel, we've only used like 14 minutes. Should we go beyond the tech demo?
Let's go beyond. But wait, there's more. So once we built out this working prototype, we realized there's a bunch of different areas we want to go, but we're going to talk about these three here today. So 3 of the areas that we've taken quotes into are how do everyday people create and share playable quotes? How can you embed quotes into a web page? And what new modes of communication are available? What are things that you can do with quotes that you couldn't do before? So let's talk about some of those. So in terms of creating and sharing quotes, you can do this now if you go to 10mile.quote.games. We have a working prototype online, and this is what it looks like. So the way it works is I have this cool open source game called Tough. This is what we used when we were experimenting with building this out. And what I can do here is I can go and go to a portion here, and then I can hit record new quote. And
can you gesture up there?
Oh, yeah.
So it's a little bit hard to see, but while he's playing, it's trying to give him feedback on how much of the ROM he's touched. And as he brings his character to different rooms, it's telling him he's used 1% or 2% of the ROM at this point. It's trying to give you feedback on how heavy is your quote going to be when you go to export it.
So I've gone around and played a little bit. I've touched 2.2122% of the ROM. I can stop recording. It takes a little while to make it. And here is a quote. So now I have this image file. I can go share it online. I can also click play. And so now here I am. It's showing my old gameplay. And at any moment, I can click here, take control, and I can start playing around in this. So that's how you make a quote. And let's go and look at some of the other things that we've made. So here are quotes that we've made. One of my favorite games is The Legend of Zelda. This is a game that my brother and I really loved, and this moment was like really impressive to us. I remember we actually went and got graph paper and copied down this raccoon here. But now I can click take control, and so now I can go and explore around in the game. But you'll notice if I do something that wasn't part of that original quote, it resets. So I try to leave this map, that doesn't work. I try to go over there, that doesn't work because I didn't record all the different ways that link was facing. But that is a playable quote of that particular moment. Anything else that I should talk about, Adam?
I don't remember. Go
on. So I think we did it.
There is something. Yeah, go back to one of those quotes and let's use the quote viewer to unpack the zip and sort of show all those pieces that we talked about.
Oh, right, yeah. So here's the quote player, and you'll notice up here it says, /play, and if I type view, and there. So this is the visualization of this this quote. So the code here will take this image, give you a view of the sliced ROM. Here's the ROM validity mask. Here's the text that we put in the README.
And the README has stuff like the hash of the original game. So if you find a quote later, you're like, but which version of Zelda did this come from? It's like, well, we're not giving you the whole game, but we will give you some metadata about the thing that came from, so you can sort of verify its source.
And then here are all the button presses that we did. So that is how you can create and share a quote with 10 Mile. Similarly, how do you embed a quote? So who here knows about web components? All right. Well, for those of you who haven't used web components, it's a cool thing where you can make your own HTML tags. So if you want to bring back Blink or Marquee, you can do that. Similarly, if you want to use a quote, maybe in an essay that you're writing about, your favorite game or your collection of favorite games, you can now embed the web component, and it's just like using normal HTML. You can put in the source here a little PNG of that quote, and you can say whether you want to have controls, whether you want it to autoplay, do all that kind of stuff.
One extra thing about that is that that element is scriptable. So if you want to do things, no, we'll just show the next demo, which will highlight the scriptability of our new little embeddable component.
So the next demo is showing things you can do with quotes that you couldn't do before. So this here is a guided tour of the Game Boy game Metroid 2, and it's a Google Maps style interface. So here what you see is a map of the Metroid 2 game, and I'm going to zoom in here. We worked with a speedrunner who went through and recorded quotes of all these different key moments in Metroid. And so I can click on any moment here. Here's a quote, but here's something that you couldn't do before. If I click on Trace, down in the corner, if you look over here, you can see it played, but what is this? What's going on here?
We added this feature like 6 days ago.
There we go. So as so yeah, now you can see the actual live playthrough, and because it is an emulator that we're running, you can pull out the X and Y coordinates of where Samus is in the game and render it on a map like you see there. This is also online. You can go to m2.quote.games and experiment with this yourself. And so that's another aspect. Part of how that works is the quote was embedded using a web component, but then some JavaScript was attached that then interfaced with this map here that you see on the screen. So many of you might be thinking, like, this is cool, Game Boy, but what about modern games? What about modern stuff? What about modern stuff, Adam?
Okay, we did this, it plays 8-bit games from the 90s, but can it do like PC games? Well, you got to be careful when you say PC games, because would you be happy with me making playable quotes for the IBM PC? Like, in terms of technical specs, in terms of its mass storage or memory, it's pretty similar. I mean, ROM is not a hard disk, but we'll get into that later. But I think the bigger source of challenge is going to be it's just a matter of numerical scaling, right? Hard drives are only 100,000 times bigger. Memory is only 1,000,000 times bigger. The amount of memory you can touch each second is only 10 million times bigger. But let's think through what it would take to do this in the future. And I will say, at the time that we submitted our talk proposal here, we only knew how to do Game Boy, and we thought, well, we'll give a talk on that. And then so a lot of this stuff is stuff we come up with in the intervening time since submitting the proposal. So if you think of, before we had this book metaphor for quoting, the ROM is like a fixed book and you want certain pages of ROM. But to quote software off of a hard drive, this is like you want to quote from a book that people are constantly writing into, and how you read the book is changing how the book is being written, and you still want to make a quote of it. So we got to stretch the metaphor a bit, but I guess these days it's kind of convenient that a hard drive is really just another memory chip. So that's a consolation prize. Another thing is that the software you might want to quote, it's not even on the hard drive. It's an app that somebody dynamically downloaded. it's a chunk of code that was emitted by a just-in-time compiler, or is part of a web page that loaded after the computer booted up. So the software is not on the hard drive to start, but if that software ran on your CPU, it must have been in memory at least for a little bit at some point. So it's all pointing back to memory here. Another thing that's different when you try to go beyond Game Boy is like, we don't want to just quote the game. There's little bits of game states spread across this whole stack here. Think about modern games use shaders, or they might use the GPU to accelerate their particle system. So there's game states spread across many layers of hardware and software. So when we want to figure out what data is needed, anything at any of these layers could be reading and writing the data we need. Is there some audio feedback? Okay. But I don't know, ultimately, at least in the emulator or the virtual machine, the state of all these different things is, it's somewhere in memory. But the speed at which you can access memory is just absurd. You know, your modern computer that does 2 billion things per second, each one of those 2 billion things, those instructions were being fetched from a memory, probably a cache, but from a memory. Executing each one of those instructions might touch multiple places in memory. Each one of those separate memory access things could be the first one that is the one to go out of bounds in the quote that we might need to add to our allow list. So we've got to sort of put our code for logging in the innermost loop of like within a single machine instruction. And worse than that, it's not just the processor that can read and write memory. Like the hard disk can say, hey, I want to do some direct memory access. So there's memory transactions coming in from all over all the time, moving tons of memory around, and the software we might want to modify, like PC virtual machines, some of these things like struggle to run the virtual machines already, let alone us adding instrumentations that's going to slow them way down. So it's like, how is it that modern processors are even able to implement memory protection? Well, they have like dedicated hardware memory management units with things like a translation look-aside buffer to accelerate these memory allow list checks. And we certainly don't have access to that in JavaScript. So going beyond Game Boy, my lab is looking at how we're going to do this for N64 and some other things, but there's a lot of ground to cover.
So what have you got? So at this point, this is sort of how Adam and I feel. We're like the two spiders, and we're thinking like, well, you know, what we have so far feels a bit like that web, but if we can pull it off, we'll eat like kings. So what have you gotten working so far in the lab?
Oh, yeah, we've done the N64 stuff, but I really want to get these PC games working. Do you know of any like web-based emulators for PCs?
So has anybody here heard about the V86 project? So tell us about V86.
Okay, we looked into this one. I guess in order to get nice high performance, able to run things like Windows 95 in the browser, it's written in Rust, and that Rust code dynamically generates more WebAssembly code on the fly. It's pretty complicated, it's pretty interesting, but there's a lot of cool demos that are built on it. What's a little bit tricky is that some of our monkey patching tricks that we were able to do for JavaScript, because this thing is written in a compiled language, we can't just dynamically substitute our own implementation of an array or something like that. And on top of that, if we could, this thing is constantly writing more and more code as it executes, so we'd have to like instrument the code that's being generated on the fly. It's just a small matter of programming, right? Okay, you wanted me to do quotes of PC games. You're not going to like this demo. Look, it's a PC. I'm running Windows, and there's a game, but it's going to work. Okay, it boots nice and quickly. You could down here I want to draw your attention to. This is a visualization of the. Oops, how do I zoom in? I think my keys are being trapped by that thing. There's little M's in here for the parts of physical memory that we read during Windows boot, and down here, when Windows booted from a floppy drive image, you can see it didn't touch all the floppy drive sectors, so there's parts of the disk that were not used. That's sort of the thing that's, both of those are playing the role of a ROM here. I can sort of reset my statistics here to say like, well, now that we've booted, how much memory is Windows touching just to sit here rendering at the desktop? And this is what the Windows desktop used to look like. And it's not much memory. So I'm going to go turn on mouse lock for a second. I'm going to launch a PC game, Reversey. We're going to like play a few moments of it. You can see I'm starting to touch a little bit more memory. I actually had to touch a little bit of disk because reversey.exe had to be like loaded from the floppy. And I'll quit back to the desktop. And now I'm going to enter this sort of simulated quote playback mode. So it says if we were to make a quote at that point, we would have only brought in about a quarter of a megabyte. So now when I interact, I'm only allowed to touch things that were on my allow list. So hopefully I should be able to launch Reversey again and make similar moves. I should be able to quit. But if I try to run trusty notepad.exe so I can do some programming, if I actually double click it, unceremoniously down here it says disk out of bounds at sector 86. Or I could have done something different, like accessed one of these menus that I hadn't used before, and it would have said memory out of bounds at some particular page. So we've got the hardest part of quoting working for a PC emulator running x86. And lots of stuff targets x86. Sorry, it's only the 32-bit version for now, but we'll work on that eventually. One of the things that I like about this is that we were actually able to do this without touching the Rust code of the project. There's this project called Binarian, a WebAssembly compiler toolchain, and one of its just command line flags that it supports off the shelf is this instrument memory pass that will rewrite an existing WebAssembly binary to, before every memory access, call out to some other function, which we implement in JavaScript. So it's kind of fun that like beneath the lowest level of individual machine instructions is the fluffy high-level JavaScript there, sort of a strange loop across scales, if you will.
So that's great, Adam, but can you run Doom?
So calling a JavaScript function inside of a machine instruction with the demo system I just showed you, no, that would not be suitable for running Doom. Like the virtual machine boots, it's just super slow. But by running that super slow demo, we got a sense of what actually takes the time, and we actually got some major speed ups. So I'm going to show you this other demo here of our advanced instrumentation demo. Ooh, look. Doom is running, nice, smooth. I don't know exactly what the frame rate it is, depends on whether I'm plugged in here. But there's so much memory in this larger virtual machine that I can't just show you individual pages. But down here, it's a little bit hard to see. We have a little WebGL canvas showing 1 pixel for each 4 kilobyte page and saying like when is the first time that we've accessed that memory. So we're doing our memory tracking fast enough that you don't feel it in gameplay. We're about maybe 2x, or it's maybe, what's it called? 2x slower than the original thing, but because the CPU does more than just memory accesses, you don't actually notice it. And just to, like, I can press buttons, it really is running this. It's not just a canned video there. And I can reset the statistics here. Let me show you just one cool thing. Reset these. Pay attention down here. When Doom starts up, it's going to go read lots of memory as it sort of zeroes out all the stuff it's going to use. So you'll see, ooh, you saw it like access all that memory while it's zeroing out the memory it's going to use during gameplay. So it is really doing that tracking. I would love to give you lots of details on how this part actually worked, but it's kind of complicated, and we just sort of got it working like super recently. If you want to learn more about the general technique we're using, which we're calling like just-in-time binary instrumentation, there was an excellent talk at DEF CON a couple years ago with the title Hacking WebAssembly Games with Binary Instrumentation. The big idea here is that we need to generate code that runs quickly, but we need the code generator itself to run extremely quickly because that compiler is running, it's competing for my host CPU with the virtual machine itself. So the code is a little bit messy, but you can learn more there.
So that's where we are now. There's a lot of territory to be explored, and we'd love help. So if any of the things that you see here on the screen look interesting to you, we'd love to talk with UX designers that can help us teach users how to create and edit quotes. If you're a software developer, of course, we'd love to see quotes in more areas, like QEMU or MAME or other similar systems, just opening up this capability to more areas. And then if you're a writer, if you want to write about your favorite games, we'd love to have you include a quote into that writing. And then lastly, just want to point out that it's more than just me and Adam. There's a whole team behind us, including people like Sanctum, who've gone through. Sanctum is the speedrunner, and then the other folks that you see here are the other collaborators that we've had on this. So just want to make sure that we give a shout out to them. But also thank you all for watching, and yeah, that is Playable Quotes. Thank you very much.